All right, guys, let's get started with today's topic. Today we're looking at administering services. Okay, so by the end of today, we should know exactly what a service is. We should know how to configure some of the service configurations, such as the type of startup, okay, whether it's automatic, manual, or disabled, or delayed start. We'll look at the idea of actually dependencies and the requirements for a service to run, and obviously the authentication requirements, as well as a few other things. Okay, more specifically, we're going to concentrate on two pretty important services in any network, and that's going to be the DHCP and the DNS service. And we'll have a chance in our worksheets to actually configure both services. Okay, configure a DHCP server to allocate IP addresses and other information to your client machines, and to actually configure DNS and understand how DNS works, and hopefully specifically how it works with Active Directory is very important for Active Directory. And obviously what happens if the services don't actually run properly. Okay, what steps we can do, like for example, stopping the service, restarting the service, etc. Okay, so first of all, let's actually understand what is a service. Okay, so we call it a service, but really it's just a program. Okay, so a service is just a program application, just like any other program you might be running. Like, for example, I'm running this PowerPoint program in front of us to put the display onto the screen. But the key difference between a service and a application, if you want to put it that way, is that the application is really for the person who's sitting at the computer, looking at the screen, and it's in the foreground. What does that mean? That means it's right up in front in your face, and you're interacting with it as the user. Okay, and it's probably the application is probably usually designed for the single user sitting at the desktop, like this PowerPoint. Okay, whereas a service is a program, but it's running, but you usually don't see what it's actually doing. You don't see any functionality in front of you. But what happens is it's actually performing a task or providing a resource to the network or the users, okay, or on the computer. So it doesn't necessarily have to be to the network, but it has to be for users, whether that be local users or network users. So if you can't see them, how do we know they're running? For example, if I actually open up my task manager here on my computer in front of us, this is just a Windows 10 client computer, but even on a client computer, you can see that there's a whole heap of things running. For example, you can see that there's a whole heap of things running, like my Google Chrome, my Outlook, PowerPoint, Skype for Business, VMware, Task Manager. They're like I said, the applications, they're designed for the individual user who's sitting in front of the computer, and you can interact with it as the user by basically getting information out of it or putting information in and getting it to do something. Whereas behind the scenes, like I mentioned, there's a whole heap of background processes. Because this is a client machine, most of this background processes is really for the local machine again, but it's in the background. It's not in the foreground. Foreground is right in front of you. You can see it, interact with it. Background is behind the scenes doing its job. And these are what I would call services. Okay, like I said, the services doesn't necessarily have to provide a service to the network. It could be to the local computer, and being a client operating system here, most of the services is for the local computer anyway, but you don't really see much of it. You don't interact with it directly. So let's have a look. So there's a VMware NAT service. Okay, hopefully you guys will remember from 4IVM that NAT in this case stands for Network Address Translation, and it translates from a private network on VMware to the bridge network or to the physical network. And this service is actually doing that translation for us. And if we actually turn off this service, it won't be able to perform that function. Okay. If I actually switch to my server virtual machine that I always use as an example, let's have a look at some of the services that might be running here. And obviously there's plenty of services, some of which we've configured, some of which are already there by default. But this is my server machine, and just like any Windows, whether it's Windows 10 or the server, you can right click on your start menu and go to computer management, which will start up this server management in fact, and you can which will start up this computer management, and from here you can actually look at the services function. Okay, so if this is one way. Another way would be from the server manager, going to tools, launching the services management console, and this is just by itself, whereas that computer management is an MMC which has got a whole heap of other tools all bundled together. So if we look at some of these services, guys, if we look at these, you can see that there's a whole heap of services, some of which we could just easily look at and understand, some of which we probably have no idea what they do. So let's actually pick something that's actually easy to see. Okay, so for example, there's the DNS server. So this virtual machine that I've got in front of us is a typical virtual machine that we use for this class. It's a domain controller, and it's also a DNS server. So if you haven't heard me say this, if there's no DNS or DNS is not working, your Active Directory will not work. Okay, so a lot of the times when you can't join a domain, you can't do something, it might be because your DNS is not functioning properly. So this is the service that controls DNS. Let me just quickly give you an example of what it's doing. So with DNS, if you remember DNS, hopefully you remember, DNS, its main function is to resolve fully qualified domain names into IP addresses. So therefore, if I do an NS lookup, server1.w2k16ad.local, which is our example domain in our worksheets, it should, when I enter this command, this is just a command line command to test the DNS. So the NS lookup stands for name server lookup, and I'm looking up this specific fully qualified domain name, which is server1 in the domain w2k ad.local. Okay, and then when I've gone and used my DNS server that's in my configurations. So obviously, you remember how we configure the TCP/IP settings. We specify who our DNS is. So from that server, we've asked, who is this server1? And they've given me an answer of 192.168.20.2. Okay, and that's the DNS server replying to me. That's the answer. This is the question, this is the answer. Okay, so that's how DNS works, and this is how specifically that NS lookup works. And I'm saying that because of this particular service being, if you look at it, the status is it's running. Okay, it's currently working. That's why we were able to resolve that name. Okay, so if with a service, we can obviously start it, stop it, and restart it, and do a few other things. So I can actually select this and right click, and I can stop it, restart it, and pause it, or if it's stopped, I can start it. So let me just stop it for you. So that's one way of doing it. Another way would be that you could just use the buttons up here, just like you would be using it on your like MP3 player or video player. I'm sure these symbols are really really obvious these days for anyone. So if I go back to that command prompt and I press up and I ask the same exact question, guys. I asked the same exact question, but this time it doesn't give me an answer. It doesn't give me an answer because the service that's actually responsible for answering that question is off. Okay, it's just like if you're calling your mum on her mobile phone, her phone's on and she'll answer it, and you can talk to her. But in this case, if I've just turned her phone off, I switched it off for her, and you're trying to ring her, you'll get no reply. And that's effectively what's going on here. I've stopped that DNS service, so therefore it's not working anymore. Therefore, it's not answering your request for your question, and that's what's happening. So let me just show you what happens now. So that service is off. Okay, I've stopped it. But just like I said before, you can restart it up. So here's I've got it selected. I'll use the play button here, or start service button in this case, and it will start up. Okay, now the status is running. And now I press the up arrow and I ask the same question again. And because the service is actually running, it can answer your questions again. Okay, so that's one specific service, and as you can see, there's a whole heap of other services, all configured with various different functionality. But forget about the individual service here. What we want to know is how we can administer these services. Okay, there's a couple of things. Like I said, first of all, you have to understand what the particular service does. Okay, so in this case, resolves DNS names, actually allows you to use Active Directory, and so forth. The second thing is, so basically, if you don't know what that is, have a look at the description. Okay, usually it gives you a hint of what it's doing. It may not describe everything it does, but obviously this gives you a start. The second part is what is the status? Okay, is it on? Is it off? Okay, if it's on, it's working. Running, it's working. If it's not running, then it's not working. And then the third thing is the startup type. Okay, let me just open up the properties of this particular server that we've been working at. So if I right click on this, like I said, I can stop, I can pause, I can restart, but I can go to properties as well. Okay, within the properties, you can actually again have a look at a few interesting things. Like I mentioned, the startup type is set to automatic. What does that mean? It means that when the operating system or the server starts up, this service will start up automatically. You don't have to go in, double click a button or tell it to run. It will run automatically. And that's a good thing because we don't want to have to go to a important service and because the server restarted, it just doesn't work anymore because the service didn't start up. So having it as automatic means that it's always going to start up when the server starts up. Okay, but we don't have to make it automatic, obviously. So there's a couple of options. We can have automatic, we can have manual. What manual means is that by default, it's not going to be started up. And if you do want to start it up, you have to go in here or somewhere else and manually tell it to start up. Okay. So why would someone use this? Well, you wouldn't use this for any important services that must be running all the time. Okay, you would only use manual for a service that you don't want running all the time, but you occasionally want to turn on. Like maybe it's a logging service, maybe it's a diagnostic thing, maybe it's some tool that only needs to run occasionally. Okay, so I would if you want to set it to manual, then that's what you have to do. You have to go in and manually turn it on, start it up. Okay, just like I had to manually start a PowerPoint today by double clicking on the PowerPoint presentation. It's just like that. Okay. Then there's disabled. Okay, this is this is even more different than automatic. This is actually turned off and cannot be turned on. Okay, what does that mean? That means it's, the service is not running and you cannot manually turn it back on. Okay, so in order to actually turn on the service, you have to change it from the disabled startup type to either manual or automatic. But if you leave it as disabled, you cannot even manually start it up. Okay, like the name suggests, it's disabled. It's not turn onable, if that's a word. Okay, so in the last option, which I sort of described as last, is a little bit complicated. It's not really, but it's a little bit different. The other ones are pretty obvious. But this automatic delay start is just like automatic, but it's not straight away. Okay, as the name suggests, it's delayed. What does that mean? That means it waits for all the other automatic services to be turned on first, then this one gets turned on. Okay, why would you have this? Maybe it's not a critical service, so you want the critical ones to be turned on first, or maybe this service actually relies on a whole heap of other things working. Okay, so if it relies on a whole heap of other things working, then it can't actually turn on before those things actually get turned on. So maybe we'll set it to automatic delayed start and set all those other things it depends on as automatic. So this one turns on afterwards. You know how it is. You can't actually put on your shoes without putting your socks on first, right? So basically your shoes will be automatically delayed, and whereas your socks is automatic. Okay, so you do that first, then put on your shoes. If that's a silly example now, I think about it. All right, so let's actually go, and even from here I can stop, pause, resume, start the service. Okay, so there's a couple of ways of doing this. So remember how I spoke about dependencies or things that depend on? There's actually a tab called dependencies. So basically, dependencies, just like I said, okay, if you want to drive a car, you're depending on the car having petrol. You're depending on the car having full charged battery, and you're depending on the fact that all these other mechanical things are working properly, aren't you? All right. So even though your car is the end result, because in order to run that car, all those other little things behind the scenes underneath needs to be working as well. Okay. So this is just like this with this service. Okay. This is a DNS server, but it really needs. It's depending on, in this case, the Active Directory domain services. So if you remember, I said that when you have a domain, you have DNS. The DNS is super important for the Active Directory to actually work. Well, it's actually integrated with Active Directory in this case, and it depends on Active Directory working. You need some auxiliary function drivers for WinSock. You need remote procedure call, and you need TCP/IP protocol drivers. Okay, so these are all the things it depends on. So if one of these things is not actually running at this point, this service cannot operate or cannot even be started. And you can see that there's a second box here. This is actually other services that depends on it. So in this case, the DNS server, nothing else uses it as a dependency. But if we actually go to the remote procedure call, and look at the dependencies, you can see that it depends on some things, but there's a whole heap of other things that depend on it. So a service can be dependent on other services, or it can be a dependency of other services. Let's go back to that DNS server again, because obviously, like I said, that's a easy one for us to understand. So that's the dependencies tab. Okay, there's a couple of other tabs as well. Let's look on the Logon tab. So basically, when a service actually runs on your computer, it needs to have some sort of privilege. What does that mean? It means it needs to actually have the permissions to run on your system, permissions to access your file system, permissions to do things on your computer. And basically, this particular service is actually getting the permissions of the local system account, which is representing the operating system. And that's a pretty high level powers, okay, as far as services go. So basically, this service can access parts of the file system, the operating system, because of that access level, okay? So we shouldn't really mess with this if we don't have to. Okay, for example, for a service that's like DNS, just leave it as is. You shouldn't have to change this. But there'll be other services. Let's say that you work in a company and one of your programmers in the company have developed this app that's for your company to do something. It needs to be hosted on this computer, the server, and you want it to start up like a service and it's operating like a service, but you don't want to give it the operating system level privilege. Then you can give it some other service account level. Okay, there's various levels. Okay, so there's networking service, there's local system, there's a whole heap of other ones, and you can actually create your own system accounts as well. Then there's the recovery tab. So basically, what does this means? What happens if this service doesn't start up correctly? So it's set to automatic, isn't it? So it should be starting up every time your computer starts up. But what if it doesn't start up properly? So here, based on the fact that it's not started the first failure, so it didn't start up properly the first time, you'll restart the service. Okay, sometimes it could be just that at that point in time it couldn't start up properly, or at that point in time it was depending on something that wasn't started up correctly. Remember how we talked about dependencies? Yeah. So basically, by setting it to restart the service, it gives you another chance to restart it.
So, like for example, if something was relying on whatever the service was,
yeah,
would that start up until that started up?
If it's a dependency that it can't start up without its dependency, then it won't be able to. Okay. So and so basically that's the first time it failed. It could be those reasons like I mentioned before. But on the, what happens if it fails again? All right. In this case, we've told us to try again. Basically, try to restart the service again. But what happens if it keeps on failing? Okay, so it could possibly not ever start because there's a problem. Okay, so in this case, we've by default it's configured to take no action, which means just leave it. Okay, so this is the counter. How many times? When do you reset the counter? If it's basically restart the service after 2 minutes. So wait 2 minutes between these things, and it restarts the counter basically every time it logs on. But we can change this as well. So for example, instead of actually taking no action for the last one, we can tell it to keep on restarting service. We can run a program. Okay, this program could be an email program informing the administrator that, hey, there's a problem, you need to look at it. It could be something else. It could be a diagnostic program. It could be any program you want or script you want. You could restart the computer. So basically, sometimes you know how it is. If something's not working, have you turned it off and on again? So basically, restarting the whole computer may prompt whatever problem that was there that it can't restart or can't start to go away. All right, so basically, we can choose one of those actions, and we won't do that. And we could actually enable actions for stop with error. So basically, this is all the things. All right, let's get back to our PowerPoint before we totally lose track of where we're going at. Okay, so there's a whole heap of services in that service management console, and obviously it's there's too many to go through each individual one here. But to be honest, you're probably only interested in the ones that are either giving you a problem or you want to do something. So if I were you, understand the ones that you need to know. Do research on any ones that you need to know but you don't know. Okay, for example, what does the net logon service do? I don't know. Go look it up. Read the description as a first point of view. And obviously there's a whole heap of resources everywhere online, isn't there? Have I talked to you guys about the Microsoft TechNet site? I'll talk to you guys a little bit later, but basically the Microsoft TechNet website is a site for technical people or administrators, programmers, anyone who's working in a technical field with Microsoft products. So if you have something that you want to ask, you want to look up something, you want to find how to do something, that's a good website to actually get help from other people or search their database for solutions to problems that you might be having. But it says have a look at page 77 to 81. So obviously this is on that reference book that's in the Learn site. So it gives you a bit of a description on all of these. But to be honest, like I said, as you'll probably learn these ones as you need to learn them. Okay? When you have a problem, when something's not working, or if you just want to do something with a particular service. Like I mentioned, you can actually open up the service management console for a couple of different ways, and doesn't matter how you get to it. You basically get a list of all the services. You can see their status, you can see their startup type, and from here you can start, restart, pause, stop the services. Okay, or change the configuration by going to the properties like I showed you. Okay, so services. So those are some basic services, and you'll find that all services end up in there. But we all know that services can get pretty complicated. So there's a couple of different types of services. There's services which are provided by Microsoft as part of the Server 2016 operating system. Okay, for example, when we actually installed Active Directory domain services, we added that as a role, and that actually installed that service onto our server and made it an Active Directory service. So basically, those are built into the operating system that we bought from Microsoft, and these are provided by Microsoft as roles or features. There's also third-party services. What does that mean? When we say third-party, when we're talking about Microsoft, it's not your company, it's not Microsoft, it's someone else. Okay, it could be Oracle. Okay, it's not. Yeah, so basically, it's someone else other than your company and the Microsoft company. Okay, third-party is someone else. Let me give you an example. Like for example, the Microsoft Server 2016 is a really good server for optimizing, providing service to people in the network. So it's an operating system. But what if you want to run Oracle Database? Oracle Database is not an operating system, okay? You don't expect it to have any operating system functionality. It needs an operating system to run on top of. So why can't it be 2016? Okay, it can be, in fact. So you can actually buy this third-party service from Oracle. You get the installables, and then you install it on top of Server 2016, and that becomes what's called a third-party service. So it's not a service that's provided to you by Microsoft. It's not something you've written from your company, but it's from another company. There's also additional services that you can actually install onto your server from Microsoft, but this is not part of the package that you buy with the operating system. So with the operating system, you got a whole heap of roles and features, which is great, and that's what it should give you. But what if you want something more? What if you want a Exchange server, which is the email server? What if you want Microsoft SQL server, which is another database server? What if you want SharePoint? So all of those additional services that can, again, sit on top of the Microsoft Server 2016. 2016 basically is the operating system. Then you put these services that's, in this case, from Microsoft on top of it. Okay, so essentially, you've these services that you're talking about, additional add-on services from Microsoft, they probably will cost you more money. Okay, you've got a certain level of services that you get from the Microsoft Server 2016 operating system. Okay, but if you want to then get the Exchange and put it on top of it, you probably have to pay for the Exchange as well. So like I mentioned in my demonstration, there's different startup types. Okay, automatic delay start, manual, and disabled. Okay, and we can configure it by going to the properties and going to the general tab and so forth. These are some recovery options, and we spoke about this as I was running through it. Okay, you can take no action, you can restart the service, you can run a program, you can start the whole computer. And we also talked about the privilege. Okay, under what accounts privilege can the service be running at? So that determines what access level they have to other things on the computer, like the file system and so forth. So most services are running as operating system. There's a few other built-in ones, but you can also create what's called service accounts yourself. And we'll talk about that in the for AWS subject a little bit more. So that's here. The service account is a user account that's created specifically to manage a service. So this is where the different access levels you've got there, like the operating system, the local service, network service, those things are not exactly what you want. You can create a service account for yourself and give it a level of access that you're happy with. And there's nothing worse than giving a service too much access, because if you give a service too much access, it opens up the potential for that service to be compromised and for someone else to use that level of access to then compromise your entire server or your network. So a service account is an account that no one actually can be used to log on to. Okay, it's not for a human being. In this case, it's only for a service to access the network or the resources at a certain privilege. You must make sure that this account has the correct privileges. Like I mentioned, giving it too much may open yourself up to someone taking advantage of that. So there's getting back to this, there's a general philosophy in IT called what's the principle of least privilege? If you don't know what that means, it means that you give someone or something just enough level of access for them to do their job. Not more, not less, just enough. What does that mean? It means they can do their job and they can't do any more, because if they could do something more, it can be exploited and taken advantage of. So that's a principle. That's not necessarily something technological. It's something that you just should believe in, okay? And everything you do, you should be designed to giving them just enough either users or services or anything to do their jobs. We also spoke about dependencies while I was giving that demonstration. Basically, a dependency is a list of other services that is required for our service of interest to actually use, okay? If those services are not running, our service that we're looking at probably can't run either. In this case, there's EFS is depending on the remote procedure call, and if that service is not actually running, our service called encrypted file system cannot run. With the services, we can stop, we can start, we can restart, and we can troubleshoot. Okay, so basically, it's pretty straightforward, and I gave you a demo on it when we first started. Starting a service means turning it on, stopping, turning it off. Restarting means turning it off and turning it back on. And with the troubleshooting, it's just like the different recovery types. Let's focus on two specific services now, okay? So the first one is DNS, Domain Name System, okay? And its main function is to actually resolve. That's the correct word, okay? Some people say translate, but the correct word is resolve. It resolves a fully qualified domain name into our IP address. Okay, that's what's called a forward lookup. Okay, so so basically, I'll give you an example. Does anyone know the URL of Facebook? Do you guys know the URL for Facebook? Yeah. What is it? Yeah. No, just the name. Yeah. www.facebook.com, right? Yeah, that's easy to remember, isn't it? Pretty easy to remember for us humans. Okay. Pretty easy for us to remember as humans. That is www.facebook.com. As a human being. All right. So, do you know the IP address of Facebook? Wouldn't have a clue, and probably most 99.99% of the human beings in the world probably won't know it. Okay. And guess what? The thing is, it probably changes all the time. Okay. So if I actually use that NS lookup function and look up the www.facebook.com, it actually gives me an IP address, okay, for it. And this IP address, there's no way I could remember it. And there's probably 20 different other IP addresses at least for the same Facebook, depending on where we are in the world, which server is actually on, and the dynamic nature of IP. TCR, what's our servers, okay? So basically, what I'm trying to get at is names. Easy for humans to remember, okay? I can remember Facebook. I can probably remember half a dozen other websites quite easily, okay? Google, Microsoft. Yeah, pretty much it's easy to remember their names. And I probably could work out their URLs. But the IP address is no way I could remember it, okay? But the key thing is humans like names, can remember names. But computers, as you know, don't use names to communicate with each other. They use IP addresses, don't they? So therefore, DNS resolves the names that humans like to remember into the IP address that the computers need to actually use to communicate. So pretty much DNS is in every part of our lives these days. As if you use anything that's IT, internet related, you're probably using DNS. Okay, if you're in a network with Active Directory, definitely using DNS because, like I said, no DNS, no Active Directory. So in Active Directory, DNS actually provides what's called the service records. So when we log in, when you guys all walked in here, you turn on your computer and you typed in your login information. You actually sent that to our domain controller, didn't it? But how does your computer know which computer is the domain controller? Okay, how does your computer know which domain controller is actually up and running right now? So basically, when your computer wants to log in, it actually queries, which is basically another word for asking a question, of the DNS server, and it asked, who is my LDAP server? Who is my Kerberos server? And being a Active Directory integrated DNS, what it actually was able to do was that, hey, you're asking for an LDAP server? Well, your LDAP server is server1.w2k16ad.local. And that happens to be 192.168.20.2. And then it redirects your client computers will then send your logon information to that particular computer. So these things that I just showed you are what's called service records, okay? So if we go to PDC, there's a whole heap of, here's the LDAP, okay? So basically, when we have Active Directory integrated DNS, the DNS provides these service records so that we could find the specific services like logon service, LDAP, Kerberos, those servers and who's providing that service on the network. We mentioned how there could be multiple domain controllers. So it basically gives us a whole, if we had more than one, a list of the ones that can provide the service, and we go to the one that is actually functioning. So it's one of the key requirements of Active Directory. So if you've never heard me say it, you probably hear me say it a million times from now on. No DNS, no Active Directory. So whenever you have a problem of joining your computer to the domain, usually what I find is when I help the students, either they've got their IP address wrong, they've got their DNS wrong, they've typed their DNS name wrong, or they're not even on the same network. So always check those 4 things, and you probably solve 90% of the problems that you might encounter initially where you're learning this stuff. So DNS name resolution is enabled through the use of tables. Okay, I just showed you that sort of in my demo. So here we have tables. You have a name, server 1. You have an IP address that matches up with that name. So when someone's doing the NS lookup server 1, it actually goes into this table. It's called a zone, and looks up server 1, gets the IP address, and returns that information to the person asking it. All right. The tables are associated with partitions of the DNS server, and they're called zones, and they contain what's called resource records. A forward zone, forward is a direction, isn't it? Forward means name to IP addresses. Okay, name to IP addresses. A forward zone that links computer names to IP addresses. It holds holds host name records called address records. And in IP version 4, these host records are called A records. In IP version 6, they're called quad A records or 4A records. When you install DNS on a domain controller in the domain, the for lookup zone is automatically created for you, and it's actually integrated with Active Directory. There's what's called dynamic DNS as well. Okay, so you might have heard of this term dynamic DNS in the elsewhere. But here in Active Directory or in Microsoft, it's a modern form of DNS that enable clients' computers and DHCP servers to automatically register your client's IP address in DNS, so we can use names instead of IP addresses. And you know, with client computers, their IP addresses can change all the time. So it's dynamic because it's changing. It means it automatically updates those entries. So dynamic DNS update protocol enables information in the DNS server to be automatically updated in coordination with the DHCP server. So if the DHCP server gives your computer a certain IP address, that then updates the DNS records with that particular IP address. That's what it's saying. So that takes us to our second service that we're going to look at today. Okay, so we'll be doing worksheets that's to do with this. The second one is DHCP, or Dynamic Host Configuration Protocol. Okay, so dynamic means it's changing. Host is your client computer's configuration. It's the configuration. Protocol is a way, okay, a method. So it's a method of configuring your client computers with information that is dynamic or changing. So basically, the basics of DHCP is that it gives your client computers IP addresses, also the subnet masks, also the gateway, also the DNS servers, and there's many other bits of information it can also give your client computers. Okay, so the DHCP in general has a pre-assigned range of IP addresses that it can give to new computers which go online and ask for an IP address. Microsoft DHCP server can support the following: can support dynamic configuration of DNS server forward and reverse lookups records. So that's what we were talking about before, where we can update those records. Microsoft DHCP server can have up to 1,000 different scopes. So a scope is a configuration. Okay, so basically we can have up to 1,000 different configurations, which means we can have 1,000 different networks that it gives IP addresses to potentially. It can have up to 10,000 DHCP clients. Okay, so obviously these are all upper limits, and to be honest, DHCP is not a super duper high resourced service, so it's not super. It's not that impressive. Benefits of DHCP. Okay, just think about it. If you didn't have DHCP, you would have to manually go around and give IP addresses. We've done that in our worksheets. It's for one client computer, isn't it? It's not a big deal, but to be honest, you wouldn't want to do that for 1,000. Okay, and what's worse is if you're manually doing something, you probably could make mistakes. You could use the same IP address over again. You could type one of the IP addresses wrong, etc. Okay, so basically DHCP reduces that sort of grunt work, so you can actually focus on more important things. So with DHCP server, you can automatically configure IP addresses. You can correctly configure information such as DNS, gateway, and so forth. Client configuration is updated automatically. So if you decide, hey, my DNS server is not working, I want to use this other DNS server, I don't have to go back to those 1,000 computers and manually rechange it. I can actually just update my settings on my DHCP server, and basically those computers will get it next time. It's a common source of network problem is eliminated. So duplicate IP addresses, mistakes, so forth is eliminated. Trust me, just me troubleshooting my students all the time. One of the common problems is that people type the wrong IP address in or wrong settings in when they're manually doing it. So if that can happen on just one client, just imagine 1,000. Okay. So without DHCP, you will have to manually enter the IP address. You will manually enter all the other information like gateway, subnet mask, and so forth. But every time you manually do something, you have the potential of making a mistake. Communication and the network issues can result. Well, if you have a duplicate IP address or if you type something wrong, then you're going to have problems. It's not good for a computer that constantly moves. Let's say you got a laptop. You move from one class to another campus to another place. Well, if you had a static IP address, you have to change it every time manually. But if you set a DHCP and every one of those networks has a DHCP server on it, then it can actually automatically be configured. So how does DHCP server allocate an IP address to a client? So basically, this client computer is set to obtain automatically. So basically it's configured that way. It's actually when it turns on, it actually asks for an IP address and the DHCP responds and gives an IP address. But after a while, this client machine, there's what's called a lease. The lease has a period, a time frame, and the lease would expire. And before it expires, the DHCP client will, if it's still on and needs the IP address, will renew the lease. Okay, so you can have a mixture of DHCP clients. You can have a non-DHCP client, which means it's got a static configuration, and you can have other DHCP clients which might be reaching the end of the lease and renewing. So how does it work? So we've got two DHCP servers here. We've got many clients. Here's a DHCP client. When it turns on, when your computer turns on, it doesn't know who the DHCP server is. It doesn't even have an IP address. So what it does, it actually uses what's another. You guys, have you guys done WNF and starting ForSyn? Yeah. So besides the IP addresses, is there any other addresses you learned about? MAC address? Yeah, MAC address. It has a MAC address, doesn't it? It has a MAC address. So what it does is uses a broadcast MAC address, which is the FFFFFF. And all the F's, whatever, and sends it to everyone. It's what's called a DHCP discover. Okay, it basically say, hey, is there a DHCP server on this network? And basically it goes to everyone. It's a broadcast, and it goes to these two DHCP servers, and they both, in this case, respond and say, hey, I'm a DHCP server. It basically say, would you like an IP address? This is what's called a DHCP offer. And goes to everyone, and it's a reply again, broadcast again, and only this computer which asked for IP address in the first place say, hey, that's great, can you give me one? And it broadcasts back, and this is what's called DHCP request. And finally, this particular DHCP server, which has been authorized in this network, will broadcast back, here's your IP address, take it. And then because this is the computer who's asked for it, it's the one that only gets it. This whole process is what's called DHCP DORA, discover, offer, request, acknowledge, DORA. Okay, and not for this subject, for SYN and such, you probably have to remember the process. So what happens when you got an IP address from a DHCP server, but it's running out of the lease is running out? So it's a bit like if you guys have rented a house or apartment or something like that, you have a lease agreement. Okay, agreement is for 1 year, and basically when the year is coming up, your landlord probably say, hey, you've been a good tenant, I'd like to keep you. Here's a new contract for another year. Okay, would you like to renew the lease? And obviously, if you want to keep that house or apartment, then you sign it and you renew it. But if you don't, you don't sign it. Okay, it's a bit similar to the DHCP. When your IP address or the length of time you've been given for the IP address is about 50% expired, it will try to renew. Okay, it basically short circuits the DHCP DORA by cutting out the first two parts. So it's a DHCP request and a DHCP acknowledge, and then your lease is renewed. But if it actually couldn't renew properly, so if the client fails to renew when it's 50%, it'll try again at 87.5%. And if it fails to renew at 87.5%, it will actually wait. It starts the whole DHCP process over again. How does DHCP interact with DNS? DHCP can register the client records into DNS zones by using the DNS dynamic updates like we talked about before. To use the secure DNS dynamic updates, the DHCP server to the Active Directory DNS update proxy global group, you need to add this server to a global group. And the DHCP policy, you need to automatically assign settings based on the fully qualified domain name and register workgroup computer with guest DNS suffix and disable the pointer registration. Pointer is for the reverse lookup we haven't mentioned just yet. So DNS, remember we said there was a for lookup zone. That's from names to IP addresses. There's also what's called a reverse lookup zone, which is from IP addresses to names. There's also these things called DHCP relay agents. So if we have multiple different networks on our in our network, multiple different subnets. Okay, you guys have learned about different subnets, and we have things like routers that that connect these different subnets together. But we don't necessarily want a DHCP server on every network. But in order for it to give an IP address to the computers on each network, it needs to exist on each network. So what does that mean? That means that on the DHCP might be on this subnet, subnet B, but instead of having another DHCP server here on subnet A, you can have what's called a DHCP relay agent. And that can be another server 2016, or it can be just a router. But what happens is that on subnet A, if these computers need an IP address, they'll broadcast, and this DHCP relay agent will receive the broadcast, but instead of actually responding directly to the clients, it's going to unicast, which is just to a single machine, to the DHCP server, get information from the DHCP server, and send the information back to these clients. It's like it says, it's acting like a middleman, a relay agent. So DHCP authorization. So basically, DHCP can cause a lot of problems if it's not doing its job properly. So what does that mean? I'll give you an example. Like in the past when we've been teaching this class, some students have had their laptop. They've actually created their DHCP server on their computer. They halfway finished a class and they said, oh, the class was over. So they said, oh, I'll take my laptop and I'll just finish the worksheet in the library. And you know what happened? Instead of actually being on the host-only network, they suddenly put on the bridge network. And as a result, it was giving all the computers in the library IP addresses from his worksheet rather than from where they're supposed to be getting. So as a result, they had all these problems with computers that couldn't get onto the internet, couldn't log in, etc., and they tracked it down to the fact that someone had what's called a rogue DHCP server. Okay, rogue DHCP server is basically a DHCP server you're not in control of. So with DHCP server with Microsoft, you can actually have what's called authorization. So if you have multiple DHCP servers in your network, and you might have this for backup, obviously redundancy, you should only authorize one of them. Okay, what does that mean? That means that these DHCP servers check with the domain controller to see if it's authorized, and if it's authorized, that means this guy is allowed to is allowed to give IP addresses out. Whereas when the second DHCP server checks with Active Directory to see if it's authorized, because the sub one's authorized, it's going to say you're not authorized at this point in time, and you're not allowed to give DHCP information out. So that's one way of controlling DHCP servers. So in this case, when a client broadcasts for IP address, only the authorized DHCP server will respond, not the unauthorized one. So a DHCP scope, like I said, is a configuration, and usually it's configured for a specific network or subnet. And basically, in that configuration, you'll have a network ID, lease duration, a name for the scope, the network subnet mask, the network address range, any exclusion zones, and that is for a specific scope, that configuration. All right. But if we had another scope, that could be a totally different configuration. So we, like I said, the Microsoft Server 2016 DHCP server can have 1,000 different scopes, meaning 1,000 different configurations. DHCP reservations. Okay, so reservations, just like it sounds like, for example, if you want a restaurant and you reserve a table for free, it means they're going to set aside a table for free for you to come in and use. So with DHCP reservation, it means that, hey, that's that printer at the back of the room. That printer should really always get the same IP address, shouldn't it? Because everyone's using it. If its IP address changes, it might mean that the configuration people are using might be different. So therefore, in order for that to have a same IP address, I can either give it a static IP address, or I can actually set a reservation. And the way a reservation works is that in your DHCP server configuration, you will have a MAC address matched with an IP address. So when this MAC address asks for an IP address, you will give it the IP address it's being matched with. And they always get that. There's many DHCP options, and the options means these are configurable information. Okay, obviously the IP address, the default gateway, DNS name, DNS server, Win server, many other information. Okay. There's also a DHCP database, and in this database it has your scope information, your address leases, your reservations, and in Server 2012 as well as 2016, it is stored in this area. When it says system root, it's basically your Windows folder, wherever that might be installed. And the DHCP database files include these files. And basically, hey, why do we even need to know that? What if we actually changing? What if our DHCP server explodes? Okay, that's a very severe scenario. But what if it explodes? So all that information we just configured, and we said we could have 1,000 different scopes. Well, do we have to do it again? We possibly could, and it's probably not as bad as something else. You're not as bad as recreating like your whole what's your project for the whole semester or something like that. But it's still a lot of work, isn't it? So what we can do with that database is we can actually back it up. When we back it up, it's just like anything. We put it offline, and if this DHCP server explodes, like we said, we just build up a new DHCP server, and we get this DHCP backup, and we restore it. And basically, instead of creating those 1,000 scopes like we said we potentially could, it is actually going to be there for us. So a DHCP server can automatically back up to a DHCP database to the backup directory on a local drive. If the DHCP database fails for whatever reason, we can take this backup and restore it. Or we can actually back it up offline, and if the whole server dies, we build a new server, we'll restore this backup. And basically it's an ongoing process. Reconciling DHCP database. So basically, what if we have a different situation, like as in the database and the information are different. So in the DHCP database has a detailed IP address lease information. And the registry has a summary address information, and basically it compares the two, and this is called reconciliation. It's basically comparing. It's like balancing in your books. Okay. Here's an example. On your registry, your client has this IP address. On your database, it has this IP address, and they match up. Okay. So after reconciliation, the database has entry confirmed. We can also move a database. So for example, this is an old database, old DHCP server. This is a new DHCP server. We back it up, we restore it. So the reason for this old database being offline could be that it's actually just old. We want to replace it, or it could be just it exploded. Okay, like I said, that's pretty severe. So obviously this is going to contain information, isn't it? this database. That information could be very sensitive because it gives you basically the IP addresses of potentially all your important servers that you make reservation for. So you should actually secure and monitor your DHCP server to prevent unauthorized computers from obtaining lease. So for example, what if someone just plugs in their computer? They could get an IP address quite easily. That's how normally it works. But if we can actually secure our DHCP server by not giving it to any computers that's not authorized. So ensure that unauthorized users do not have physical wireless access to your network. Enable auto logging for every DHCP server on your network. Regularly check and monitor auto logs. Use the 802.1x enabled LAN switches. So you'll talk about that when you go on with your Cisco. You have Cisco network access protection, which actually then allows you to prevent computers that you don't trust from getting access to the network. And then Server 2012 has NAP, which actually validates the system before it gives an IP address. What about restricting unauthorized non-Microsoft DHCP servers? So like I said, if you have unauthorized DHCP server, they can cause a whole heap of problems. So to eliminate unauthorized DHCP server, you must locate it and either physically disable it or disable the DHCP service from running on it, because it can cause a whole heap of problems. Delegating DHCP administration. So when we say delegating is just letting someone else do the job. In order for someone else to do the job, you need to give them permissions. Okay? So when we say delegating administration, we're basically saying giving someone else permissions to administer the DHCP server, to change the scope, to change the information, to create new scopes. To delegate who can administer the DHCP server, you should limit this membership to only the DHCP administrators group. Add users to the DHCP users group if they need to have read-only access. If they need to be more than read, DHCP administrators group. So administrators can view and modify the data. Users can only look at the data. There's also DHCP statistics that you can gather, and this is gathered at the server level or the scope level. And obviously this gives you statistics you can look at. Not super useful all the time, but can be useful if you want to have a look at how your servers are performing. Because let's say you've got a scope of 200 IP addresses. But if you look at the statistics, it's saying it's using 198. Then obviously you're going to run out of IP addresses eventually, aren't you? So maybe you need to either increase the scope or you actually have to create a new scope. Here's the audit logs. So like I was saying, for the security, we need to audit what's happening, when the server was started, restarted, etc. It keeps a log of all those events. And Windows Server can be configured with DHCP role by adding the DHCP server role. And like I said, it can be integrated with DNS by using the dynamic updates. And we can also reserve specific IP addresses for specific computers or devices like the printer. We can actually update computers on a network with particular change. So for example, the DNS server's changed. We can update all of the computers. DHCP can provide the service to multiple networks, and we can also omit a certain range of IP addresses or IP addresses from the scope. What does that mean? It's called an exclusion. So if our range is from here to here, we can exclude this range from that big range for other purposes. For example, that might be what the servers use. Okay? So that's the end of the presentation. What I want you to work on is the worksheet 7. And like I said, if you haven't already started your assignment by this stage, you should be well and truly into it. Okay? So if you haven't started it, it's time to really get started.